Hi. Today I want to run this electric motor on a UPS. So let's do that. Let's plug it in. Let's plug it in. Turn it on. What? Not turning on. Stupid UPS. What's going on? Okay. So apparently there's something wrong with the UPS. Let's check if the wire, if there's a fault with the wire or the UPS itself. Let's get the wire and measure the resistance. First and foremost, in this video, I want to give a big thank you to Mr. Cliff Gallia, for donating the UPS in this video. Thank you, Mr. Gallia. Let's short the wire so we can measure the resistance. Let's get our precious multimeter and measure the resistance. Let's check the multimeter. As you can see, it makes a noise when the contacts are shorted, which means that the multimeter is good. And I have to check if there's continuity between the lines of the plug. Obviously this can't fit in. I checked them before the video, but never mind. On the wire, connect it. Don't ever do this on electricity, this is just for continuity checking. If there are power flowing through this wire and I shorted it, and you do what I did, it should explode. So don't do this if there's power. As you can see, the fuse is not blown. And if we check the earth, it's good. So apparent problems in the UPS. And I don't know how to fix UPSs and it's not worth fixing one, so let's take it apart. So now to take the UPS apart, so first put the plug aside as we won't be needing that. I have to get a screwdriver set. Now the screwdrivers I usually use in my videos, which are these, don't work, seeing as they are either too thick or not long enough. So I have to use these to open up the UPS. To open up the UPS, I have to flip it over, as you are seeing, pretty heavy. And we get a thin and long screwdriver, Phillips screwdriver. I.e. this one. And then, down here you see the 4 screws, where the holes, where the screws are. So let's unscrew them. Next, put the screws aside and flip the UPS over. And we're going to take out the top cover, as you are seeing. But first I have to flip it over again. And use a small screwdriver, like one of these, to pull this out, like this. As you are seeing. Like that. As you can see. Next, we flip the UPS over, and this should come out. It's coming out. As you can see, it came out. Flip it over again. And as you can see, we have the UPS. First and foremost, you disconnect the terminals from the battery. From the lead-acid battery. This isn't really easy. You see? Next, we see the circuitry. If you want to continue assembling the UPS, there are many screws on the transformer you unscrew those when the transformer goes out. On the circuit boards there are screws. You unscrew those when the circuit boards come out. And for the lead acid battery, just pull it out. Now I am not going to disassemble it further so far, because I have a drill battery which may work for this purpose. And if I'm correct, the lead acid battery charging circuit is destroyed and the inverter circuit is not. So, and unfortunately I have a high current drill battery down there, so let's test it out. Let's see if the inverter circuit works. Let's do that. Okay, so for this experiment, I drilled two holes in this UPS, put the wires back in, and re-drilled the and reassembled the UPS. So now we can connect any 12-volt power supply we like without having to open the UPS and change the power supply. So not only is it inefficient, but there's limited space in the UPS, and the screws eventually wear out and it becomes difficult to open and close them. So this is a great advantage. So now let's get some scissors and cut the insulation to connect them to the drill battery. Let's do that. Okay, so now this is insulation. We cut it open, well, of the connector only, duh, or you can short the drill battery and it won't end well. So let's cut the insulation. Let's do that. As you can see, we cut the insulation on the very tip top, so we can connect it to the drill battery without too much of difficulty or without dangerous connectors. So as you can see, we have stripped these and we connect them to the drill battery. So here's the setup. The light bulb should light, the motor shouldn't run. It's not connected to the circuit because it'll draw too much current and probably destroy the battery and the power supply itself. So now we're going to get the plug and connect it to the UPS, as you are seeing. Now I get my drill battery and connect it to the terminals. So let's do that. And we have to be very mindful of the polarity, plus and minus. Reversing the polarity may cause permanent damage to the inverter. So let's do it. Okay, so we're gonna connect this load to the inverter. And before you ask, is this a proper inverter? This was made by professionals, which of course know way more than me. This inverter was made by professionals to convert 12-volt DC input over here to 240-volt AC. And to connect this to the light bulb over there, I built a harness to connect it. So let's connect it. And when I do this, I want to give a disclaimer. Don't ever connect that load to the mains, or create a high voltage short circuit and explode. So let's connect it to the light bulb and no mains, it'll explode everything. Let's do it. So now I've turned off the lights and I'm gonna connect the inverter to the drill battery. Always check the polarity. It worked! Yes! Thank you, Cliff! So special thanks to Cliff for giving this broken UPS. The inverter side works! And I can lit up the bulb! And it's pretty hot! It works! Yes! So now I'm connect this AC motor to the inverter. I modified the socket and now it should work. Let's connect it up. Yes! It worked as well. It was about 0.2 amp from the supply, so the battery shouldn't lose that much voltage that the inverter detects it and stops working. It works as well. Let's connect a bit of a bigger motor. Let's do that. now there's a bigger AC motor. Let's connect it to the inverter and see what happens. As always, minding the polarity, or else you can short the inverter. Connect it in. Turn it on. As you saw, the motor turned, but it drew too much inverse current, and the inverter cut the load because the battery voltage decreased too much. That's a shame. After all, this is only a puny drill battery. A car battery or a lead-acid battery from my actual UPS have been useful. And now for the grand finale everyone's been waiting for. Attempting to connect this washing machine motor to the inverter. Let's do it. Let's hope nothing explodes either. Once again, minding polarity. Connecting to inverter. Turning on inverter. Well, that was a fail. Let's try again. So apparently the motor draws too much inner current and it stops and keeps sitting and stops. That's what we can do about that. And after all that, it's still at full battery. And that's great. I can use it for an inverter project one day to power the light bulb. We'll try it. To conclude, this was one of the most successful videos I've ever made. The motor ran, the induction motor ran, the bulb ran. It's great. Bye and thanks for watching.